Okay, hello and welcome to another past paper session. Today's paper is November 24. The variant is 5.3. I've already solved 5.1 and 5.2. I hope those were helpful for you. Let's start solving 5.3. It is going to take me some time to calculate all of these things. So let's begin. The first question says 30% of the residents of Wimfield own an electric car. The residents are chosen at random. Find the probability that either all three own an electric cars. Okay, three residents are chosen, so n is 3. So n is 3 and or none of them owns an electric car. So either or. So it's either probability of x equals to 3 or probability of x equals to 0. So 3C3. 0.7 power 3 minus 3 and 0.3 power 3 for AC 0. 0.7 power 3 minus 0. Okay, so let's quickly calculate that. That's 0.3 cubed plus gives me 0.37. I will check my answers as I go along. 0.37. A random sample of 125 residents. So that tells me that n is large. I will need a suitable approximation to find that more than 45 of these residents own an electric car. So more than 45. Okay, so the first thing that I should do is do a continuity correction. So that's 45.5. I calculate the mean. 125 into 0.3, 37.5, I think. And variance, NPQ. 26.25. So Z greater than 45.5 minus 37.5 divided by root of 26.25. 1.561. Okay, 1.561 is fine. Let's go and check 1.5619407. So that's 1 minus 5 of 1.561. 2.0593. That should be the final answer. Yep, that is the final answer. Okay. The next question says a red-sided, fair six-sided die has faces labeled 1122. A blue fair-sided die has labeled 112233. What dice are thrown is a product on the total scores. Find the probability distribution table. So whenever you have two dice, it's best to first do this. Make a sample space or a possibility diagram so that you know all the outcomes that are supposed to be there. Okay, so what are the outcomes? 1 into 1, 1, 2, 2, 2, 1, 1, 1, 2, 2, 2, 2, 2, 2, 4, 4, 4, 2, 2, 2, 4, 4, 4, 3, 3, 3, 6, 6. Okay, so the probability distribution table will have x is the product of the two scores. So the product can 1, 2, 3, 4, 6. How many ones? There are 6 ones, so 6 out of 36. and there are 12 sixes, there are 6 threes, there are 6 fours, there are 6 sixes as well. Okay, I think that's the correct answer. 1 6 1/3 1 6 1. Okay, find expected value of x. That's simple. That's just x into p. So the first sum was 1. It had a probability of 6/36. Then the next sum was 2. It had 12/36. And 3, which was again 6/36. Then it had 4, which was again 6/36. And then it had 6, which is 6/36. Okay, so that should come out as 3. Moving on to the next question. It says in Malimba, the heights of are normally distributed. So that's a normal distribution. Mean 176 and standard deviation 4.8. Find the probability A has a height greater than 170. The Z 170 minus 176 divided by 4.8. Okay, so minus 1.25, I think. So that's 1 minus 5 minus 1.25. According to my rules, it becomes 1.25. So 1.25 from the table, 8944. Okay, the final answer has to be 3 significant figures, so 0.84 then. Then it says 60% of adult males in Malimba have a height between 170 and k, where k is greater than 170. Find the value of k. So between 170 and k, 60%. That looks like a reverse reading question. 170. I just found 170, right? Yeah, I could use that idea. Let's just stick to our typical method. Zero 0.6. That's minus 1.25. Hmm. 5b is 5a. That's k minus 176 over 4.8. 1 minus 5, 1.25. 0.8944, I think. When this moves to the other side, it's going to become 0.6 plus 7056. I need to do phi inverse of 7056. Easier way would be to use your calculator and do the inverse normal function, as I've said before in the videos for the topic. But if you don't have your calculator, then you go into the table 7054 and plus 3, so 0.541. k minus 176 over 4.8, 0.541. I'm just checking if I have the correct answer. Yes, should give me the correct answer, and that's multiplied by 4.8 and then add, so 170.6. Now I will give this answer correct to one decimal place, because the standard deviation is one decimal place. Okay, that's the rule that you generally follow. You wouldn't give me an answer that says 179, although the question says answer required correct to one place. Okay, so because it's specified in the question, that's how the standard deviation was. Well, in fact, it's correct to one decimal place right here. Okay, otherwise I would also still give you one decimal place because the standard deviation is one decimal place. Okay, on a certain day, the heights of 150 sunflower plants grown by children at a local school are measured correct to the nearest. The heights are summarized in the following table. Draw a cumulative frequency graph. Before I can draw a cumulative frequency graph, I need to correct these um, classes. They will have to be connected, so 19.5 and 19.5, and then 29.5 and 29.5, and then 39.5 and 39.5 and 44.5 and 44.5 and 49.5 and 54.5 and 59.5. Okay, this would become 9.5. Cumulative frequency would be 10, 28, 28 plus 2 gives me 60, 102, 130, 154, and 1. I made an error somewhere. 44, 150. Okay, the cumulative frequency is always plotted against the upper class boundaries. Okay, I need from 10 to 60. So 10, 60, that is height. Yeah, I think. Yeah, and this is cumulative frequency. It's to go 50, 20, 60, 120, 140, 60. Okay, let's start plotting. Upper class boundary is 19.5, and I need to plot a total of 10. So there is 19.5 and there is 10, so I mark cross. Okay, then I have 29.5 and 29.5 and here 39.5 and 60, 4.5 and 102, 4.5 and 102. Then I have 49.5 and 130. 4.5 and 1, 4, and 59.5 and 160. Okay, let's join these with a curve. Okay, and that looks like a good cumulative frequency curve. Use a graph to estimate the 30th percentile. So 30th percent of 150. 45 is 150, right? 45. So I'm looking for the 45th value. The 45th value will appear here. That looks like 86 to me. 36 centimeters. Let's check if that is the correct answer. Yep, that is precisely the correct answer. Any answer between 35 and 37 would be acceptable. Okay. It says mean and standard deviation for the heights of the 150 flower plants. What I would suggest doing is making the uh, midpoints and the frequency table here so that we can do some easy calculations on the go. So the first midpoint would be 10 plus 9.5 plus 19.5 divided by 2. You will also do plus 9 divided by 2. And the first midpoint is coming out as I think 14.5, because for mean and standard deviation you need the midpoints 14.5, and then we have 24.5, 34.5. Here is 10, 4.5, 34.5, 32, 42, 20. 14, 6. Okay, then next last boundary should be 55 plus 59 divided by 2. It's 57. The one before that should be 2. The one before that should be 47 and 42. Okay, so the mean is then simple. Mean is just sum of fx over sum of f. Okay, so let's start multiplying. 14.5 into 10, 24.5 into 18, plus 34.5 into 32, plus 42 into 42, plus 47 into 8, plus into 14, plus 7 into 6 is a 5840 divided by 138.9. Let me check if that is the correct answer. 38.9 is the answer. And for standard deviation, you first do variance. Variance is sum of x square f over sum of f minus the mean squared. Okay. Again, I would just calculate this with the squares. Luckily, I have it on my calculator, so it's going to squares everywhere. That gives me 244,285 divided by 15 minus 584 over 15 whole square. 150, sorry, 150. 112.762. We get root of that, and the standard deviation is therefore 10.6 if I am correct. To get the 5 marks in one go. Yep, that is the correct answer. Okay, then question number 5, it says a factory produces 30% of chocolates. 30% of the chocolates are wrapped in gold foil, 25% are wrapped in red foil, and the remainder are unwrapped. So how many does that leave? That leaves 45% as unwrapped. Indigo chooses 8 chocolates at random from the production line, and the probability that she obtains more than 2 chocolates that are wrapped in, no more than 2 chocolates that are wrapped in red foil. So I want to calculate the probability of x less than or equals to 2, and my success is getting red foils. So 0.25. So I calculate the probability of 0, 1, and 2. I write down my expression 8C0, 0.75 power 8 minus 0, 0.5 power 0, 8C1 power 8 minus 1, 0.25 power 1. I have to add these up. It's C2, 75 power 8 minus 2, 0.25 power 2. I've shown you this before, that my calculator, go to menu, go to distribution, and since I have to accumulate in this case, I am going to say binomial 1, 2, 4, 2, and 8, and 0.679. Okay, I think that should be the correct answer. Let's see. Yep, that is the correct answer. Jake chooses chocolates at random, one at a time at random from the production line. Find the probability that the first time, so this tells me this is now a geometric. He obtains a chocolate that is wrapped in red foil is before the seventh choice. The before the seventh choice is. So I want to find the probability of x less than or equals to 7. The formula for that is prime minus q power r minus 1. So 0.75 power 7 minus 1. 0.822. Let's check if that is indeed the correct answer. Okay, this is Kaifa chooses chocolates one at random from the production line. Find the probability that the second chocolate chosen is the first one wrapped in gold foil, given that the fifth chocolate chosen is the first unwrapped chocolate. So given that, okay, so given that is conditional probability. Fifth is first unwrapped, and second chocolate chosen is the first one wrapped in gold foil first. Second is gold first. Okay, so that's slightly confusing. Let's first figure out the denominator. It's fifth is first unwrapped. Fifth is first unwrapped. First unwrapped. That means that in the first four, what I could get is I could get either the red or the gold. So that's going to be 0.3 plus 0.25. That's going to give me 0.55, then 0.55, then 0.55, then 0.55, and then I want an unwrapped one for the first time. So that's on the fifth. Okay. Then in the numerator, what I want is second is gold first. So the second chocolate is the first gold. So what I'm going to do is I'm going to figure out the places. So that's the first gold. So that would be 0.3. Then I also want the second condition to be satisfied here. Why? Because the given condition, basically comes up with an and in the numerator. So the fifth one has to be 0.45. The third and fourth could either be gold or red. So 0.55 into 0.55. Okay. And the first then definitely needs to be a red one. Why? Because I need the first gold on the second turn and the first unwrapped on the last turn. Okay, so that's what my numerator is going to be. Let's calculate that. I think that's 0.0102. That's what I calculated earlier when I was figuring this question out. Okay, what is the denominator? Let's check that. That comes out as, if I were to calculate all of that together, the answer would be 30 over 121 or 0.48. Okay, so tough question there for 5 months. Then we have permutations and combinations. Let's see that. Okay, arrangements of the letters happiness. So 9 factorial, 2 factorial, 2 factorial. That's easy. That's should give you 90720. Find the number of different arrangements of the 9 letters of the word happiness in which the first and last letters are not the same as each other. Okay, so that is slightly challenging because if you try to make two combinations, a little lost. So the only way that they could be the same as each other is if you have P at the start and P at the end, or you have an S at the start and S at. What I'm going to do is I'm going to subtract them from the totals. Okay, so if you have a P at the start and P at the end, that means the 7 in the middle and 2 of them are S, and then 7 in the middle and 2 of them are again P's, another dash. Okay, so 90720 minus 2 times 7 factorial over 2 factorial. Let's check if that is the correct answer. Yep, that is the correct answer. Eight five six eight zero. Yep, 85680. Okay, that's the easy way of doing this question. Okay, this part says find a number of different arrangements of the 9 letters of the word happiness in which the two P's are together and there are exactly 2 letters between S's. So whenever you have 2 letters between S's, you just have to make these cases where you fix the positions of where the S is, 4 and 5. Then this could be another variant. Okay, of a mistake here. Let's just try to avoid that mistake. Okay, so let me put the dashes there. Not that you need to put the dashes, but I need to explain to you this question, which is why I'm doing it this way. Okay, then I want what? I want the P's to be together. Okay, so if the P's are together, they suddenly can't appear here. So this one presents a problem to me. Okay, and they can't suddenly appear here. That also presents a problem to me. Otherwise, so what I will have to do is I will have to think about all of these cases separately as to where the P's can appear. So where are the P's that can appear? So 1, 2, 3, sorry, 1, 2, 3, 4, and 5. Okay, so there are 5 places where the P's can appear. The other letters can shuffle between themselves. How many other letters are there? 5 factorial. Okay, so the box that the P's are shuffling in is can move around in fixed positions only. Similarly, it can appear here 1, 2, 3, 4. So that's 4 ways that the box can appear, and then there are other 5 letters that can appear. Okay. Similarly, let's see 1, 2, 3, 4. 4 places, and then the others are 5 factorial because they're always 5 factorial that way. Then 1, 2, 3, 4, and 4 into 5 factorial, and then 1, 2, 3, 4, That's it. So 4 into 5 factorial. And 1, 2, 3, 4, 5. 5 into 5 factorial. Let's check if I am getting the correct answer out of this. I'm not absolutely sure on this one. 5 into 120 gives 600. And this should also be 600. 4 into 5 factorial. 4 into 1, 480. So 480 into 4 plus 1200. That is the correct answer, 3120. I think that's the easiest way that I could explain to you this, because making cases is essential whenever you have a fixed number of letters separating other letters. Then says the 9 letters of the word happiness are divided into a group of 5. Probability, right? Okay, so the denominator in this question, it says the 9 letters in the word happiness. Because I'm trying to find probability, the denominator has to be the total number of outcomes. So I have 9C5 into 4C4. Then I have to decide what the numerators are. So the 2 P's and the 2 S's are in the other group. If you assume that they're in the group of 5 and there's a group of 4, there are 2 P's here, then the 2 S's definitely have to be here. So how many more people do I need in this group? 3. How many more do I have available? I will have, because the 2 S's got separated and 2 P's got separated, I'm left with 5 other letters. So that's 5C3 into 2C2. Okay. Then it could be the other way around as well. I could have the S's here and then I could have the P's here. So in that case, I would be selecting I would again be selecting 5C3 into 2C2. Yeah, that's the correct way of doing it. Let's say if I quickly do this, 5C3 plus divided by 9. I am getting an answer that says 10 over 63. And that is indeed the correct answer. Okay, so the ending portion of this paper was tough. The rest of it was easy. Thank you for watching.
Welcome to Edge Learning, where we are changing dreams into success stories. Let's go. At Edge Learning, we offer courses to help you excel. Whether you're preparing for the SAT, aiming for IBA and LUMS, need O and Olevel tuition, or IELTS coaching, we have the right program for you. Forget about boundaries. We offer learning anywhere, anytime. Our expert tutors provide personalized attention in various batch sizes and one-on-one sessions, along with pre-exam review workshops to ensure you perform your best on test day. Join us at Edge Learning and take the first step towards turning your dreams into reality. So what are you waiting for? Register now or call us.